Angle relationships, as it says. We're going to take the 4 types of angles that we talked about yesterday, which I can't remember what those were, Jack. Do you remember?
Acute, obtuse.
Acute, wait, what were the acute ones again?
Under 90 degrees.
Under 90 degrees, but bigger than 0, because we don't have any negative angles. It's starting to come back to me. Okay, go ahead.
Obtuse.
Obtuse, which ones?
Over 90.
But less than
180.
180. Okay, good. Those are the bigger looking ones like that, right? Okay, and then the third one?
Right.
Right, which is?
90 degrees.
And then the fourth one?
Straight.
Straight, which is?
180.
Which looks like?
Line.
A line. Very good. Okay, so we're going to take those 4 types of angles and pair them up. And so now we'll have pairs of angles, because there's 2 of them, versus individual angles. So the individual angles will be paired up to give you pairs of angles, like it says up there. There's a whole bunch of them. That's what I just said. And that's what I just said. So this is our first type. Adjacent. What does the word adjacent mean? Next to. They're 2 angles that are next to each other. There's some pickiness in there, however. It's not just a matter of being next to each other. They have to share a common endpoint and no common interior points. Now, why do we care so much about it? Well, let's look at some things that could be maybe considered adjacent angles but aren't. So let's take this angle over here and we'll put this angle over here. Those appear to... Question?
I was going to say like
Do so.
they don't have the same.
They don't share the same endpoint. Okay, so they appear to be adjacent, not by our definition. The other instance would be if we take this same picture and we talk about this angle versus this angle. Not adjacent because they share some common points over here. Okay, so pretty much 2 angles next to each other, but again, there's a little bit of idiosyncrasy in there. We good? Remember, when taking notes, you don't have to necessarily write down everything, nor do you have to write down the way I phrase it. If you can paraphrase the definitions into something that makes more sense to you, by all means do so. You might also want to include a picture. But again, that's entirely up to you. Now we good?
Yeah.
Number 2, vertical angles.
Question.
Cough or a sneeze? Sneeze. Gesundheit. Could have been mistaken as a cough. Wasn't a snoff, was it? Sneeze and a cough at the same time? No? Okay. We have 2 lines that intersect at a vertex. It forms 4 angles. The angles across from each other are called vertical angles. Vertical angles do not have to be vertical like you know the word vertical. They're just across from each other. So there's 2 pairs in that picture, as it says down here. 1 and 3 are vertical angles. 2 and 4 are vertical angles. Even though we're not ready to talk about it, what do you think the relationship would be between angles, let's say 1 and 3? Oh,
They're the same.
they're the same. Our fancy mathematical term, they're congruent, okay. So we would say they're equal if we're comparing their angle measures. 45 degrees to 45 degrees, we'd say they're congruent if we were talking about their shape and their size. Notice we also have some adjacent angles in this picture. Michelle, which angles up there are adjacent? Just give me one example. There's a whole bunch, but give me one.
Adjacent 2 and 3.
Perfect, 2 and 3. Yeah, 1 and 2, 2 and 3, 3 and 4, 4 and 1. Okay, but we're just focusing on the vertical angles. We good? Hot diggity. Linear pair. Okay, so Gesundheit. The difference between a linear pair and adjacent angles is that the linear pair has to form a line. So you'll notice that same picture, 1 and 2, or no, you said 2 and 3, right? So we talk about 2 and 3. 2 and 3 are adjacent angles. However, the difference being is that their non-common side, this guy, forms a line. Okay, so what is the measure of angle 2 plus the measure of angle 3? 180, correct. So the two, anytime you have a linear pair, all of these things have to add up to 180 degrees because they have to be a straight angle, or a line if you prefer. So remember the relationship I talked about with golden retrievers? Yeah?
Yeah.
Does anybody not? Okay, you weren't here. So all golden retrievers are dogs, but not all dogs are golden retrievers, right? We use that relationship a lot. It pops up again here. Are all linear pairs adjacent angles?
Yes.
Yes. Are all adjacent angles linear pairs? No. Okay, good. And like I said, that comes up a lot, so we'll be going over that over and over again. All right, so now let's take what we know and incorporate it into a nice little algebraic problem. Based on what Paul told us, what do you know about those two angles? Those two angles being the two that are marked with algebraic expressions. Paul, what's true about these two?
They're congruent.
They're congruent, so what should you do with those algebraic expressions? Set them equal to each other, solve for x. Go ahead. Then, after you get the value of x, make sure you answer the question. It wants to know how big is angle CAT. Don't be bashful about busting out those calculators. Who's missing? Why do I feel like you're just like the rustle of the calculator grabbing. Love it. Famous last words. Done. Again, remember the procedure. Once you get an answer, lean over to your neighbor or lean forward or lean backwards. Check with your neighbor to make sure he or she has the right answer. If not, figure out who made a mistake.
You sub in one of the equations, and then like whatever that is on the line. Like I did the 16x minus 20, I subbed it into that one, and since it's on a line, then the other side for C8 is gonna be no, that line is gonna add up to 180.
Did you check with somebody?
Oh, yeah.
Subtract 180 from what you get.
What are you giving them a thumb? What does that mean? Being weird? Okay, you guys work that out. Good. Check with somebody. Awesome. Awesome. You guys are good. Still working it out, but okay. You should be ready to go. If you want to change, I think it's set for red. If you want a different color, pick whatever color you want. while she's working, it appears that it's Grace, right?
Yeah.
It appears that Grace got 6.75 for X. How are we feeling about that before she continues? Okay, good. Beautiful. Golf clap. Well done. Okay, let's see if this makes sense. So she set the two equations equal. Solve for x, that's a 4, not a 9. So 4x equals 27 and x is 6.75, which we all agreed was the correct answer. Now Grace, could you talk us through the last part of the problem? What did you do to get your answers here?
I plugged it into 16x minus 20 and plugged x in.
Does it have to plug in here?
No, it could go.
Could have put it down here?
Yeah.
Okay, you chose this one. Put it in there and you got
88.
88.
And then since the angle CAT adds up to 180 with the other one, I subtracted 88 from 1.
Good, and we're going to find out what that's called in a second, but they are a linear pair, and she realized that this is a straight line, so it's got to be 180 degrees. 180 minus 88 equals 92. Perfect. But I got a question for you, Grace. Is there anything about that problem that bothers you?
It's long.
Okay, good. I got other things to be doing.
It says it's 92 degrees, but it's not. It's an acute angle.
Excellent. Anybody else catch that?
Yeah.
Angle CAT in the picture is an acute angle. However, mathematically it shows us that it's an obtuse angle. Which one do you trust? Yeah, trust the math all the time. It wouldn't be beyond some geometry teacher to draw the pictures incorrectly just to see if you're paying attention. Okay? Any other questions on this? We solid? Good, pretty straightforward. Now, in geometry, we're not just going to take Paul's word for it and say, well, Paul said these angles have to be congruent, so they must be. We're going to have to do something which is called a proof. In other words, we're going to have to come up with a way to justify that why are those two angles equal? Paul, why did you say those two angles are equal? Just because they look equal?
No, because that's like what linear pairs are. Right?
No, linear pairs are angles next to each other that add up to 180 degrees. We haven't even said that yet. They're just two angles that share a non-common side that's a straight line. So how did you know that these two angles were equal? It's okay to say they just look like it.
Well, I mean, that's what, like, I don't remember how, but that's what we were taught before.
Okay, so based on past knowledge, you remember that those were equal. Have you guys seen that before? You knew that already? Okay, good. Probably, however, never proved it, right? You were just told these angles across from each other have to be equal. We don't accept that, so we're going to prove it. That comes later, though. Okay, now piggybacking off of what Grace said, those two angles that are next to each other added up to 180 degrees. That's what's called supplementary angles. Any two angles that add up to 180 degrees. Okay, so make sure you understand the difference. A linear pair is adjacent and they add up to 180 degrees, but supplementary angles don't have to be adjacent to each other. They can be anywhere. 60-degree angle on the back wall, 120-degree angle on the front wall, they are in fact supplementary, but not a linear pair. Anybody remember what complementary angles are?
That add up to 90 degrees?
Beautiful, two angles, and only two angles that add up to 90 degrees. And as it says, they do not need to be adjacent to each other. Remember, we're dealing with pairs of angles, so if you have three angles that add up to 180, those are not supplementary. They're just three angles that add up to 180. Is any of this new? No? Maybe linear pairs? Okay. Let's start with that one. Find the value of x. And so you'll see the algebraic problems that pop up all follow a similar pattern. What's the relationship between the angles? That relationship will tell you what kind of equation to set up. Solve the equation, answer the question. And again, after you get an answer, check with your neighbor. Gesundheit. Keep clapping for yourself. Great. I solved it. Andrew, can you talk while you're working? Can you talk while you're working?
Well,
I just have a quick question for you. What are you doing with those two angles?
adding them together
And setting them equal to?
180.
Perfect, keep going. Good. Answer the other question. Try to measure the angles, and then when you're done, put it on the board. Yeah, when we get done, we'll finish the two examples and we'll go back. What did you miss?
But what they are,
Supplementary are two angles that add up to 180. Complementary, two angles that add up to 90. Oh, it's just that they don't have to be next to each other, that's all. They don't have to be adjacent to be supplementary or complementary. Just as a helpful hint, when you do come to the board, the magic pen is easier to use if you write up higher on the board, especially when you're tall like yourself. But that's fine, you're doing great. I wasn't, actually, yeah.
As long as that, as long as the vertex is on the middle point, doesn't matter, so you can call that HIK or KH. What won't work is KH.
Which means,
So they don't have to be adjacent to something like that.
Awesome. Thank you very much. Golf clap. Okay, walking around the room, it appears that almost all of you, if not all of you, got this, so we don't really need to talk about it that much. But again, those angles that are in the picture are a linear pair, which means they're supplementary. So we added them up, set them equal to 180, solved for x, and then answered the question because the question wanted to know x and the measures of the angles. Any problems with this guy? Good. Next one is a screw up. Let's try that again. There we go. We didn't talk about this, but what does that little box in the corner mean? The right angle. Okay, good. Solve that one. While you're working, what kind of angles are pictured in that diagram? Nope. We haven't talked about corresponding yet. That comes up in a couple weeks. They're complementary. Adjacent. Anything else? Nope, that's it. Deb, what are you doing with those angles?
Combining them,
And setting them equal to?
90.
Attaboy. Did you figure out what x is yet?
Yeah.
No? Okay. So 2x plus 2 plus x plus. Is my math right? Awesome. So that would be 30, and 2 times 29 plus 2 would be 60. Okay, we good? The problem has kind of a built-in checks and balances here. So if you solve for x and you get an answer, and you plug it into the angle measures, if those angle measures don't add up to 90, you did something wrong. So let's say, for instance, I did my math wrong, and I got x being equal to 20. I plug that in, I get 21 and 42. Okay, that's a problem. Why? Because 42 plus 21 is not 90. The tricky part for you is going to be recognizing, should I set those angles equal to each other? Or should I add those angles up and set them equal to 180? Or should I add those angles up and set them equal to 90? And that one you're going to have to figure out on your own. Okay, do you still need me to go back, Vanessa, or are you good?
I'm done.
Good. Okay. Now we get into some fun stuff. Translating words into numbers and equations. So I'm gonna talk you through this one for the first time so that you understand what we're doing here. But before we do that, let's start with this. Suppose I have some angle and I don't know the measure. I'm gonna call it x. Okay, so that's our angle. The value of that angle measure is x degrees. How big is its complement? Paul?
90 minus x.
90 minus x. Does that make sense to everybody?
Yep.
Let's suppose the angle is 5 degrees. How would you find out its complement? You would take 90 minus 5 and get 85. So if the angle measure is x, its complement would be 90 minus x. And seeing as you're all good at pattern recognition, what would be the supplement of that angle?
180 minus x.
Good, 180 minus x. Knowing those two pieces of information will allow you to solve these types of problems. Don't overthink them. You are literally going to start reading the problem and write down exactly what it says. And when you're done, you got an equation to solve. Okay, so watch. The measurement of the supplement of an angle. How do I represent that?
180 minus.
180 minus x. Is a key for equals. That's the only thing you really got to remember. 60 less than. How do you say, or how do you represent 60 less than mathematically?
60 minus.
The other way around.
Minus 60.
Minus 60. So we're going to take 60 away from something. 3 times the measure of the complement. How do I write that?
3x.
Emmett?
Yes.
No.
3 times 90 minus x.
Good. 3 times the quantity, 90 minus x, because that's the complement. 3x would be 3 times the measure of the angle. This is the complement. Okay. So again, all I did is I started reading the equation or the paragraph and wrote down exactly what it says. And you need to know some things like less than is minus, more than is plus, times is multiplication. Then you solve that problem. Simple linear equation should be easy to solve. Let's see, we'll bring this over here so we get 2x, and then 270 is 210 minus 180 is 30, so x is 15. Okay, so there's the angle measure, 15. How big is its complement? It's 90 minus 15, which is 75. And then how big is its complement? 165. Good. Okay. So the steps here, notice x represents the angle. We talked about this already. We found the measure of the angle. Be careful on a problem like this. What is it asking for? Sometimes I'll ask you for the angle measure. Sometimes I'll ask you for the complement. Sometimes I'll ask you for the supplement. Sometimes I'll do something crazy like ask you what is the sum of the supplement and the complement. That kind of stuff. So that idea of answering the question pops up a lot too. When you're done, make sure you've done what the problem asked you to, not what you think it asked you to. What's the word perpendicular mean? Now you heard enough out of you. Put your hand down. You answered a couple also. Let's pick on somebody else. Was that like a gang symbol you played? Are you like a math gang? What are perpendicular lines? Will, any idea?
2 lines that cross each other.
That's it? Just cross each other?
Yeah.
Okay. Can you draw them for me?
Out there.
Yeah. The worst that could happen is you're wrong, and then we'll just point and laugh, and you can go pet the dog. Okay? Put arrowheads on that because we're talking about lines. Good. Now let me ask the masses. Are those perpendicular lines? What kind of lines are those? They're just intersecting. So what's the difference then between perpendicular lines and intersecting lines? Does it begin with an M? Progress. Megan. Megan, what do you got for me?
Really cross 3, 4, 9
Ooh. It's good for you. Get up, stretch your legs.
Very strange 90 degree.
Perfect. Awesome. Do we agree?
Yeah.
Yes. Okay, so perpendicular lines are lines that intersect to form. How many right angles are up there, Megan?
4.
But you only marked one. Don't go anywhere, Megan. How many right angles are up there?
4.
But she only marked one. How's that? What'd you say?
They're congruent.
What's they?
The angles.
They are.
They are.
Why? So you're saying that, let's do this. 1, 2, 3, 4. You're saying all of those are right angles?
Yes.
Why?
Because the one with like where she drew the angle is next to the other ones, and because it forms a straight line and then
All lines are straight.
it forms a 180 degree line. Two of them, if you put them together, have to equal 90. So if one of them equals 90, then the other one must equal 90.
Okay. Everybody with her?
Yeah.
If this is 90, because Megan made it 90, she put the little box in the corner there. Angle 4 must be 90 because this is a 180-degree angle. What kind of angles are these two? Supplementary. No. Adjacent and no. Well, yeah, they are congruent, but that's not one of the pairs you're talking. And what's the somebody say it? Linear pair, correct. So that makes that 90. Same relationship with 3 and 4. However, why are 1 and 3 congruent?
Because if 2 is congruent, then 3
What?
has to be.
Because 1 and 3 are vertical angles.
Okay, good. Now that was. I will miss you. 1-5 for homework.
Okay.
Court date.
Orthodontist.
Oh yeah. So something like that. Court, orthodontist. I don't know.
Guys, they're in the same.
They could be. All right, so that was a long way of belaboring the fact that Megan is correct. There are 4 right angles there, but we're not going to put boxes in each one. By putting a box in one of them, it implies that they're all right angles. Okay, good. That took way longer than I expected, but that's okay. So there we go. Forms 4 right angles. New symbol, because again, we're mathematicians and we're lazy. We don't like to write out big, scary words. Or try to remember how to spell perpendicular, even though you can sound it out. The upside down capital T represents perpendicular. And remember, the ways that we can refer to lines are either by points on the lines or using lowercase letters. Some of you got confused on the quiz there where you thought the M was a point. If it's lowercase, it's referring to a line. Okay, we solid on that? Yeah, so we did that. This one ramps up pretty quick. The one thing I neglected to include in the picture, which might be helpful, is the right angle symbol. Where is the right angle symbol, Ben? With a heavy sigh.
No, wait, no.
Erase.
Right,
Now you're in business.
right.
Is that it?
Yeah.
Okay. Is he right? Yeah. Yes, he's correct. That's a convenient place to put it. What time are we out of here?
40:53.
Really?
Uh-huh.
Oh, we're not going to have any time to go over homework. Okay. So we'll start tomorrow. We'll finish this in a second, but we'll start tomorrow going over the 1-4 homework and the 1-5 homework. I think you can do the 1-5 without having gone over the 1-4. We'll spend some time going over that because tomorrow is just more practice of the same, so we don't have a new lesson. So that'll work out well. It'll be a homework fest tomorrow. Okay, so in the process of solving this problem, what do you notice? Or how would you solve that problem? No. Michelle.
So since MH, and KO are perpendicular, that means that like there's 4 right angles, and so you would start. So the 3x plus 6 and the 9x, those two added together would be 90.
Beautiful, because this is a right angle down here also, because that one is.
Yeah.
So 3x plus 6 plus 9x would equal 90.
And then also 3y plus 6 would be 90.
Because that's just a plain old 90-degree angle.
Yeah.
Beautiful. Good. Okay. So you see the difference between the two problems. One of them, solving for the y, is just a straight up 90-degree angle, so we set it equal to 90. The other one are 2 complementary angles that happen to be adjacent. They add up to be 90, so we did just that, add them up, and set them equal to 90. 2 simple linear equations, both solvable. See if they make sense. Just like we talked about distance, for distance it can't be negative. For angles, it also can't be negative. The variables can be negative, but the angle measures cannot be negative, and you'll see that pop up every once in a while. Is it safe to assume you could solve these simple equations?
Yep.
Good, then we're not going to spend time with it. We're gonna move on to putting a red dot on the board.
Not again.
I know, and I'm gonna leave it there. We're done. Okay, so you got 5 minutes. You can at least download the file off of Schoology into Notability and get started with that. Okay? As far as note-taking goes, I'm walking around the room while you're taking notes. Some of you are writing down way too much material, some of you aren't writing down enough, and some of you are dead on, which is confusing some of you because I haven't told you who's doing what. But if you're writing down a whole bunch of stuff, you'll start to realize that, like today's lesson, there are some things in there that you need to find right away. You might want to go back through your notes and highlight real important things, like vertical angles equal to each other, like supplementary adds up to 180. So that as you're referencing your notes, you can find it quickly and easily. Okay? Anything for the good of the cause? Awesome.